Hello and welcome to E233. I'm your instructor, Gregory Myers. In this video, we're going to take another look at an example of a for loop. This video is part of a larger series of videos focusing on the fundamentals of the C programming language known as our fundamentals demo. This video also assumes that you have watched the first few videos on loops. So to begin with, what we want to do is take a look at our for loops version 3 snip. And you can take a screen capture of it or obtain a copy of it. Either way, let's go ahead and start by putting the function prototype in our list of functions. Please note that this accepts 3 input arguments that correspond to the values in a for loop, as well as an int return value, which will be used to specify the number of iterations that the for loop runs. We also want to take a second to go ahead and copy the comments as well as the beginning of our function, and we'll simply put this down at the bottom of our file. Now, the idea is that we're essentially want to pass the values that will be used to drive our for loop as input arguments to a function. Where we obtain these values from doesn't really matter. As a matter of fact, when we actually demonstrate this function in action, we're going to do it one of 2 ways. We're going to prompt the user using some printfs and some scanfs to obtain the 3 values, but we can also simply use the command line arguments. So we want to be able to do it both ways. So essentially this function doesn't really care where you get the start, the increment, and the end, but rather that it is used then as input arguments to drive our for loop. So the only thing we really need to do is we need to throw a little bit of logic in here first to error check these values. In other words, to make sure that we have valid start, valid increment, and valid end. Now, we're going to do this in a little bit of an unusual order. And as a matter of fact, we're going to focus on the increment first, because it is very important that a for loop increments, because otherwise we'll wind up with an infinite loop. So the first thing that we want to check is simply, or somehow we want to check that the increment is in fact not equal to 0. So we've got a couple of ways that we can do this. We can directly check this, or what we can do is through a combination of if conditions, we can eliminate the 2 other possibilities. So if you think about it, there's essentially 3 possibilities: that the increment is less than 0, which essentially means a decrement; the increment is greater than 0, which is increment; or the increment is equal to 0. So we'll start off breaking this down here. I'll start off with if increment is less than 0, else if increment is greater than 0, which means that there's only one way that we can get to this possibility right here, and that means that the increment is in fact equal to 0, which would lead us to an infinite loop, because the index would never change. So before we get too far into this, we probably ought to take just a second to go ahead and create one more temporary variable, and it's also going to be an integer, and we're going to call it index. Now, please note you can do this with a double. Watch the earlier videos so you'll see some of the nuances associated with using a non-integer index for your for loops. Now, let's focus in on the condition where the increment is less than 0. Well, in order for the increment to be less than 0, that means the end must come, or must be less than the start. So if we've got this particular scenario where the end is greater than the start, essentially what that means is that this loop will never run. And you probably want to go ahead and at least warn the user by putting in a print statement. So in this case, printf, warning the increment is negative and the end is greater than the start. So in other words, this for loop will not run under those conditions. There's nothing wrong necessarily with the code, but it simply means that you will never have the for loop actually run. And we can test this if we want to, or I encourage you to test this yourself. But what we want to do now is we want to focus on the else. So implied here, although not explicitly stated or tested rather, is the not of the end greater than the start, which means that basically here, this means that the end is less than or equal to the start. Now, this still does not guarantee that this loop will run. It may run 0 times if, for instance, the end is actually equal to the start. And since that's not really a problem, we aren't going to bother to put another check in here. At this point, though, what we can do is we can simply borrow this table that I have provided for you and simply paste a copy of it into our else branch. And then what we want to do is we simply want to go ahead and write our first for loop. So in this case, for index equal to start, because that's where we want the for loop to begin. We then want to continue while our index is greater than or equal to the end value. So we can now do index greater than or equal to the end. And more importantly here, we want to focus on the fact that since our increment is in fact negative, we can still simply have index equal to index plus increment, because remember that the increment is actually negative. So essentially what that's going to do is going to subtract from the index. So thinking this through, throwing some values out here from our earlier example, let's say we start at 9, so this would be index equal to 9. We want to continue while the index is greater than or equal to 0, so index greater than or equal to the end where end is 0, and then we wanted to count backwards, so our increment would be -1, so this would wind up being index equal to index minus 1. And what we can do here is we can simply have a printf of 2 values here, one a %d for the index, and then a second %d for some operation. In this case, we're still going to just do our 2 times our index. So the first placeholder gets the index, and the second placeholder just simply gets 2 times the index. Don't focus too much on this particular operation. It's just demonstrating that we're doing something with that index value. Now, let's move on to the second scenario that we wish to look at, and that is when the increment is greater than 0. So in this particular case, what we really want to do is we want to test whether or not the end is less than the start, because the whole purpose with the increment being greater than 0 is that we're counting up. And so essentially, if our end is in fact less than our start, then we simply want to provide some sort of warning to the user. The increment is positive. I suppose there's no real need for the comma here, but that's the grammarian me getting the better of it. And so here, increment is positive, and the end is less than the start. Once again, I encourage you to think this through and see where the problem lies here. We're going to be interested in focusing more on the else branch. And in this case, what we want to do is we want to make another copy of our table, or you can just simply move the entire block of code up here to the else, tab it over, and line it up. But what we'd like to do here now is we want to focus in on the scenario where the end is greater than or equal to the start, because essentially that's the not of the if condition here. So if it fails this condition, then you know that the end is greater than or equal to the start. And we are not necessarily worried about the scenario where the end is equal to the start. That just simply means the loop will only run once. And like the previous example, we go ahead and build our for loop using index equal to start for the beginning value, index less than or equal to the end for the ending value, and then simply index equal to index plus the increment. And at this point, we can simply borrow the exact same print statement that we used in the first branch of our nested if statement. Now, I said that we wanted to have the third condition implied here. We don't explicitly test that the increment is equal to 0, but if we've eliminated the possibility of the increment being less than 0, and we've eliminated the possibility of the increment being greater than 0, then the only other scenario left is that the increment is in fact equal to 0, at which point we would also like to make some sort of warning to the user stating that in this case, we would have created an infinite loop. So in this point here, I'm just going to say warning, increment must be non-zero. And you can word that whichever way you'd like. As a matter of fact, I'll actually put a little caution in here for us, or you will get an infinite loop. Just in case you accidentally do get an infinite loop when you're running your application from the command line, just remember to hit Control-C. Now, the last piece of this example is this count variable. And the idea is what we want to do is count how many times the for loop actually runs. And so to begin with, what we want to do is before we get into any of our logic, but after we have declared the variable, we simply want to initialize the count equal to 0. And then inside of each one of the for loops, we simply say count equal to count plus 1. We also come down here and we do the same thing in the second for loop. And if you wanted to, you could use the abbreviated notation of count plus plus. Now, there are other ways to go about doing this. You can technically also derive the count from the start, increment, and end, but what I want you to do is get into the habit of sort of thinking of those as two separate things. You have the index of the for loop and the count that keeps track of how many times the for loop runs. So while we could use a formula for doing this, just simply use a temporary variable. And then the last step, of course, is that we want to return that value. So in this case, we want to return the count. All right, at this point, let's go ahead and save it. Let's build it. And we seem to have at least code that compiles. Remember that it doesn't do anything until we actually add it to our list of switches. And so what we can do is we can begin with looking at two different scenarios. The first one is going to be that we allow the user to interactively enter the start, increment, and end values after prompting them using a print statement. So we'll begin here with an else if, and utilizing the string compare I, we're going to look at the argv square brackets 1, and we're going to compare that to the for loops underscore 03 switch. And if there's a match there, and also what we want to do is we want to check the number of arguments. So in this case, what we want to do is we want to check if our argc is equal to 2. In other words, those were the only two arguments provided. This essentially implies then that the user wishes to use our function interactively. So let's see here, I appear to have a mismatched parentheses. No, parentheses are fine. I just missed one of my curly braces. All right, so this assumes that the user wants to gather the information interactively. We could also check for an additional switch, maybe a /i for interactive or /p for parametric, and we'll see how to do that in another video. But the other scenario that we also want to check is when the user provides those arguments via the command line, in which case we provide not only the /for loop switch, but also 3 additional command line arguments corresponding to the start, increment, and end values for a total of 5 arguments. So in this case, this assumed that the user provided them as command line arguments. All right, so in order to accomplish either of these scenarios, it would benefit us to have a temporary variable. So what we're going to do is we're going to come up here to the top of our main, and we're going to go ahead and declare 3 more temporary variables: our start, our increment, and our end. Now we can come down here, and through a combination of printfs and scanfs, we can collect the information from the user. So in this case, we'll have a printf, please enter a starting integer. And I'm just going to go ahead and provide the integer clue, or cue rather, to the user. It is not required. It just helps to guide the user into what information should be provided. And then we follow this up with a scanf using the %d and the address of the start variable. We replicate this now using a printf. Please enter an increment integer. Once again, following up with a scanf %d, ampersand, in this case, increment. And hopefully you're starting to see the pattern here. As a matter of fact, we could go ahead and simply copy, paste. In this case, what we want to do is we want to provide the third one as the ending integer and simply change then the ampersand increment to ampersand end. At this point, all we have to do now is make a call to our function. Now, remember that our function returns a results. In this case, it returns the count of the number of times the for loop runs. So what you want to do is you want to capture that output using another temporary variable. In this case, I'm going to create a results temporary variable that we can use in other examples later on. And what we want to do is we simply want to make a call to our for loops function. So our for loops underscore 03, and we pass to it the start, the increment, and the end. And at this point then we simply want to do another printf and something like, congratulations, your loop ran %d times, followed by, of course, a new line. And then for that %d placeholder, we simply provide the results. Now, obviously, you can put in whatever you'd like to for your printf. Long story short, just simply provide your user some feedback. Now, in the parametric example where you are providing it from the command line, we do this slightly differently using the A to I or sometimes the A to F function. In this particular case, we're going to look at the A to I function that returns an integer. The A to F simply returns a double. In this case, we're interested in integers, but it converts a string into an integer. So what we do now here is we specify the start variable, or we assign to the start variable whatever was in the argv square brackets 2. And essentially, it's the argument that comes after the switch that indicates that you want to run the for loops underscore 03. So we convert using a to I, our argv square brackets 2. For the increment, we once again use our a to I. And in this case, what we want to do is we want to convert now the next argument, or argv square brackets 3, and then our end is equal to a to I, utilizing our v square brackets 4. And just as a little comment, remember that since C is zero-based, this is your third argument, this is your fourth argument, and then the last one is technically your fifth argument. At this point, you simply make a call to the function just like you did in the earlier example. So results is equal to for loops version 3. You're past the start, the increment, and the end. And then lastly, we can print out the same congratulatory message that we had in the earlier example. Now, a quick side note, you would want to check and verify that the a to I function actually returned a usable integer. We'll handle that in a later video. But for now, what we're going to do is we assume that the integers that were provided, or the values that were provided by the user on the command line, are in fact integers. Which leads us to our help and the necessity for providing some further instructions to the user. So to begin with, what I'm going to do is I'm going to copy the example for the for loops version 2 and simply change the value to loop 3. But also remember that we want to provide that interactive mode as well as that parametric mode. So the interactive mode doesn't have any additional arguments, but the parametric mode would want to then provide some additional arguments. So perhaps something like 0, 1, and 9, which would allow for us to count from 0 up to 9. So at this point, we've written a fair amount of code. Let's go ahead and build it. And then let's come out to our command window and let's see how well we did. So in this case, I'm going to cd to my documents, to my courses, EE233, to my projects, to my fundamental demo, distribution, debug in MinGW, and typing in dir. Sure enough, I have in fact changed the timestamp on the fundamentals demo.exe, so we know we're in the right folder. And then I want to run my fundamentals demo with no switches, and sure enough, I'm going to pull up the help. And I want to start by running the for underscore loops for loop underscore 03. And just real quick, let's check to make sure. So yes, a little minor typo we've got in our help that I just noticed. You probably want to take just a second to update this. It's actually going to be for underscore loops underscore 03 to keep with the function name. So let's take just a second to change these. This is one reason why it's always good to go ahead and periodically run your code, even your help, verify that you don't have any problems. A little minor change in the documentation there. All right, let's make sure that that's changed. It is. So now what we want to do is we want to run the for underscore loops underscore 03. Since we're not providing additional arguments, this should put us in that interactive mode where we provided a starting integer, an increment integer, and an ending integer. And you'll see now that my loop ran 10 times, starting with 0 up to 9. And then we could, of course, align our value a little better, but basically did that multiplication. We can do it one more time interactively, this time starting at 0. We're going to specify an increment of 2, and we're still going to leave the ending integer as 9. And you'll see in this case, it ran 5 times, skipping over every other integer. All right, so the next thing and the last thing that we need to test in this particular example, maybe not the last thing, but the next thing we want to test is to see how our interactive mode works. And our interactive mode should be triggered by simply providing 3 additional arguments when we run it. And sure enough, it provides the same table, and it indicates that our loop ran 10 times. If we accidentally forget one of our arguments, we should get the help. And then more importantly now, we should be able to type in different increments. Which brings us now to some of the examples that we want to check to see if our logic is sound. So for instance, if I provide 0 as the starting value, -1 is the increment, and 9, I should get a warning that says the increment is negative and the end is greater than the start. So in other words, the for loop should not run at all. As a matter of fact, our message now is perhaps a little bit amusing because it's congratulating you on essentially failing to run your loop. Likewise, if we specify a starting value that's greater than the ending value, but a positive increment, then you should get a warning that says increment is positive and the end is less than the start. And now for the real test, what happens when you accidentally specify 0 as the increment? Well, you get a warning that says the increment must be non-zero, or you will get an infinite loop. So it looks like in addition to the for loop part of our code, we've also handled the triage logic for the different combinations of our start, increment, and end. Once again, I hope you found this video useful. As always, if you have any questions or comments, don't hesitate to email me, and thank you for watching.